And now, finally, we can get into the truly accurate way to conduct a sailing, called your Mercator sailing. This is the result of all of the previous types of sailings and the invention, if not discovery, of meridional parts being synthesized to create one actual accurate means of calculating the course and distance between 2 points. And you can see it's only 2 formulas. It's simpler than meridional parts or than mid-latitude sailings, thankfully. So this is the these 2 formulas alongside a meridional parts table or calculator is what a computer will actually use to find a course and distance, because it's accurate enough that you can truly understand where you will be given a certain course and distance, because it is considering the slope of the Earth, not just within a single latitude, but across all of the latitudes you will be spanning across given a single certain voyage. And you can also tell it's borrowing a lot from the mid-latitude sailing, because this formula, tangent of course angle, is equal to the DLO divided by the difference of meridional parts. That looks eerily familiar to the formula, the second to last formula used in the mid-latitude sailing, where this was just, I believe, the difference of latitude instead of the difference of meridional parts, or the mid-lat instead of the meridional parts. Clearly, we found a more accurate way to take into account the curvature of the Earth. And then this, the distance is equal to the difference of latitude over the cosine of the course angle. That's the same formula as we used in the mid-latitude sailing. So we finally come upon a system using the knowledge of the past to be substantially more accurate. So let's calculate a Mercator sailing. We're going to go from 10 degrees, 30 minutes south, 15 degrees, somehow this is always the hardest part, 45 minutes east, to 5 degrees, 15 minutes north, and 30 degrees, 0 minutes east. So we're going from the south to the north. We know we're going north, and our easterly values are increasing, so we know we're going northeast. So before we even worry about anything else, we know that when we try to calculate our course angle, we'll be in the northeast quadrant of the course angle diagram. Not relevant yet, but it's going to be obviously important later. So step 1, we find our difference of latitude. We do 10 degrees, 30 minutes south, and 5 degrees, 15 minutes north. South and north, so this time we add them together. We get 45, so 15 degrees, 45 minutes. But once again, remember, we don't care about degrees and minutes. We want this all in minutes. So we multiply 15 times 60. And we get 900. So our difference of latitude is equal to 900. Our difference of longitude, in case you're wondering, I switch back and forth between d-lat, d-long, and cursive L, lambda intentionally as well as unintentionally, both because they mean the same thing in my head and because I want them to mean the same thing in your head, and so you don't have a problem alternating between the two. So the difference of longitude is 30 degrees, 00 minutes east, and what did I label this? Oh, yeah. And 15 degrees, 45 minutes east. That was just me losing my place. Carry a 1 over, so you get a 60. So 60 minus 45 is 15. 29 minus 15 is 14. So difference of longitude is 14 degrees, 15 minutes, which if you multiply 14 times 60, you get 840, plus 15 is 855 minutes of longitude. So there's your difference of latitude, there's your difference of longitude. Now what's the third thing we need? We can't just rely on these two. Now we need to find our difference of meridional parts before we even begin. So to calculate meridional parts, you need your latitudes. You need 10 degrees, 30 minutes south, and 5 degrees, 15 minutes north. I forgot, which means you are just as easy to forget, but remember to add those leading zeros. We got to take these two latitudes and convert them to meridional parts. So we bring Bowditch over again. I lost the page, so give me a second. There we go. Meridional parts tables. First, we're going to use 10 degrees. So that's on this page. Unfortunately, it's hard for you to see. But there's the 10 degrees column. Forgot the minute value, 30. So we're looking for 10 degrees, 30 minutes. So we go to 10, all the way up to 30. It's nice, it's the start of the box, so you don't even need to bring down the leading number, 629.4. So our first meridional part value is 629.4. Next, we need to find 5 degrees, 15 minutes. So we go to our single digit section, 5 degrees. We're looking for 15. So 5, here's 15. Come across, also the beginning of a box, 313.3. So 313.3. Now, so again, we're going from the south to the north. So we're going from one hemisphere to another, meaning instead of subtracting these two, we have to add them. Same is true for the meridional parts. So we add these two together. 629.4 plus 313.3. You get 942.7. So M is equal to 942.7. Now we can start our equations. So, equation number 1. Tangent of the course angle is equal to DLO. DLO is 900 divided by M. M is 942.7. So you do 900 divided by 942. Inverse tangent, because you're bringing the tangent over to this side of the answer. You get 43. So CA is equal to 43.67, which will round to 7 degrees. Now this is when we bring that back to the course angle to course question. Like we said before, we're going northeast, correct? Going from the south to the north, and we're going more east. So northeast, meaning we label this north, 43.7 degrees east. Don't worry about course versus course angle yet. We're not converting it to course just now. We'll do that in a second. Next equation, distance is equal to difference of latitude, which is, I read the difference of latitude instead of the difference of longitude for this part, so this is wrong. 900 is the difference of latitude. So we're going to change this. That's what you get for having such a cluttered mess over here. You want to space things out so you can read more effectively. Don't make stupid mistakes. So 855 divided by 942.7. Inverse tangent of that. This is just more practice. That's why I did it, I swear. 42.2. So you can see it was really only a small difference between those two numbers, and that equates to a relatively small difference in the degree values. But our true course angle is 42.2. So difference of latitude divided by the cosine of our course angle, which is 42.2. We plug that in, cosine 42.2, 900 divided by answer, 1215. So I'll move it over here. Our distance is 1,215.03 nautical miles. That is our final answer for our distance. Now, course from course angle, CN equals CA, CN equals 180. Every time I do this, I want you to do it as well. CN equals 180 plus CA. CN is equal to 360 minus CA. Which quadrant are we in? We're going northeast. We're in this one. Hey, that's nice and easy. CN is equivalent to CA. So our distance is 1,215.03, and our course is 042.2 degrees true. Don't forget the leading zero. That is how to do a Mercator sailing. You begin with two coordinates, two latitudes and longitudes of where you're coming from, where you're going to. And you only need these two equations. For those equations, you need to find the difference of latitude, the difference of longitude, and then you need to go into Bowditch to calculate your meridional parts, find your difference of meridional parts. You throw those three values together, and that will allow you to find your distance and your course angle. Then you apply this little diagram, and you can convert your course angle to your course. And now finally, you have a course and distance to follow if you actually want to get from where you are to where you want to be.